draw the unit circle. All you freak out kids that are stumped on trig, better draw, draw the unit circle. Cosine's 1 and then square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. Quadrant was not all you find. Fill in the other quadrants, just change some signs. Now tangents all that's left to find. Take each coordinate, divide sine by cosine. All you freak out kids that are stumped on trig, better draw, draw the unit circle. All you freak out kids that are stumped on trig, better draw, draw the unit circle. Cosine's 1 and then square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. Cosine's 1 and then square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. Cosine's 1 and then square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. All you freak out kids that are stumped on trig, better draw, draw the unit circle. All you freak out kids that are stumped on trig, better draw, draw the unit circle. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. All you freak out kids that are stumped on trig, better draw, draw the unit circle. All you freak out kids that are stumped on trig, better draw, draw the unit circle. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0. Cosine's 1 and then square root 3 over 2, square root 2 over 2, 1 half and 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1 half and 0.
So how can you memorize the unit circle? Well, it's not so much a matter of memorizing it as it is being able to draw it, write it, know it, and recreate it if necessary. So it's not so much that you could say what the cosine of 45 degrees is off the top of your head. Square root of 2 over 2, by the way. Nevertheless, if you can draw the unit circle whenever you're required to, like on a final exam or in some other thing that you need it for in the future, you know, in engineering and different things like that, then you'll be okay if you can just kind of draw it out and recreate it. So let's draw it out. I'm going to use a CD so mine is nice and circular. There we go. And just to make things as straight as possible, I'm going to draw a diameter. Try to put it through the middle. And we'll draw this diameter as well, perpendicular. So here's our X and Y axes, and the radius is 1 on our unit circle. So what we're going to do is create the unit circle and put the numbers in there. And this should help you be able to memorize it. So here it goes. We're going to zoom in just a little bit. There we go. Now, most of what we've dealt with is 45, 45, 90 triangles and 30, 60, 90 triangles. Those are the special right triangles that we've done. So we need to keep in mind that the angles we're going to use are 45 degree angles. So there's 45. That's half of 90. You can kind of eyeball it and see if it's right. And then 30, 60, 90, which breaks this up into thirds. And again, this doesn't have to be perfect. And if you're just kind of sketching this, obviously it doesn't have to be perfect at all. So there we go. So let's just concentrate in the first quadrant. These should be the same amount apart, but obviously I couldn't draw it too well. So let's just start. We know it's 0 degrees here. We know this is 30 degrees. This is 45. This is 60. And this is 90. And again, that comes from just knowing those are the angles that we deal with. And let's go ahead and tackle some radians as well. 0 degrees is 0 radians. Let's switch colors just so they don't all run together. We'll make it green just for fun. So this is 0 radians. If I was going to give you some dessert, I'm going to give you some pie. The pun is intended here. I'm going to give you some pie, but I'm only going to give you that much of it, and I say, this is your pie. I'm going to give you a half of a circle, a circular pie, as your dessert. And I said, this is it. This is all you get, which is more than you need. Because, you know, it's not the healthiest thing. Anyway, this is not about a balanced diet. This is about pie. And if this is one entire pie, and don't be like, no, the whole circle will be the whole pie. No, no, this is all you get. This is all you get. Then this would be an entire pie. All the way from here to here. And this would be half of your pie. So pi over 2. And if we broke it up into other little pieces, this would be a fourth of your pie. And here we go. that, and that would make thirds. So this is a third of your pie. And this is half of your third. So it is a sixth. And if that made no sense, just kind of look at the numbers here. 2, 3, 4, 6. It skips 5. Everything here is a power of 2 or 3, or both. Okay, now we come to the song. Cosine is x and sine is y. So it's cosine of whatever, theta, comma, sine of theta. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. And it's the exact same thing counting back. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. And in the second verse it talks about how to get the other measurements. And it says just change some signs. So since we've drawn this, let's just continue with it. In this quadrant, everything is positive. And it kind of makes sense. I mean, over here it's a positive, comma, positive. Well, over here, you would have to go back and then up, so it would be negative, comma, positive. And over here is negative, negative. And over here is positive, negative. positive, negative. So we're just going to follow these lines and use some symmetry, and we're going to go from there. So if I'm going to trace this, and it's going to come down here, then this is going to be negative square root of 2 over 2, comma, negative square root of 2 over 2. So knowing the first quadrant gets you everything else. And like I said, this is in the second verse of the song. And we can kind of bring this one down. And it's negative 1/2, comma, negative square root of 3 over 2, and we trace this one across, and it's square root of 3 over 2, comma, 1/2. All right. Let's draw some other lines. And let's start filling in some other stuff. That one didn't go through the center. Oh well, we'll deal with it. Let's start filling in some more degrees. So 0, 30, 45, 60, 90. Add 30 more to that. Add 30 more to that. Add 30 more to that. 30 more. 30 more. Keep in mind that these are 15 apart. Add 30 more. 30 more. You can do this in your head. You don't even need a calculator. 30 more, 330, and then by the time you get to the end, it better be 360 degrees. Up at 366. There we go. 360 degrees. And then we'll put some, we'll put the 45s in there too. So if we add 45, then add 45, then add 45, 135. Don't you grab a calculator. Add 45. Add 45, halfway in between these two, that'd be 225. Add 45. Add 45 to that. Be 315. There we go. Okay, let's put some radians in, then we'll put a few more things, and we'll be done. All right. Pi. This is 1.5 pi's. So this is 3 pi over 2, and this comes back around, and that's 2 pi. Let's explain these pi's just a little bit better. Let's actually count by sixths. Not sixes, but sixths. This is a sixth of a pi. Every 30 degrees is a sixth of a pi. Just think about it logically. That's 1/6. That's 2 sixths. 2 sixths reduces to be a third. That is 3 sixths. 3 over 6 is a half. That is 4 over 6. 4 over 6 is 2 thirds. 5 over 6. 6 over 6. 7 over 6. 8 over 6. That reduces. That's 4 thirds. 8 over 6. 9 over 6. It's already there. It's been reduced. 10 over 6. We're counting over. 10 over 6. That reduces. 10 over 6, and 11 over 6 is this last one right here. 11 pi over 6, and this actually will be 12 over 6. 12 over 6 is 2. So now we'll count by fourths. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, it reduces, 7/4, and 8/4 is 2. There we go. Let's put in a few more sines, cosines. We'll deal with some tangent, and then we'll be done. Okay, we can use symmetry and flip this thing over. So this point and this point are the exact same. Give or take a couple signs. 3 pi over 2, comma 1/2. As a matter of fact, let's go ahead and just keep copying that. We'll fix the signs in a minute. Square root of 2 over 2, square root of 2 over 2. 1/2, square root of 3 over 2. Okay, now let's fix the signs. These are positive, negative. Positive, negative, positive, negative, positive, negative. Close that parenthesis. We come over here. We'll use the symmetry. We flip this over. Negative, positive. And 1/2 square root of 3 over 2 becomes negative 1/2 square root of 3 over 2. This is this, only it's negative square root of 2 over 2. Square root of 2 over 2. That goes there. Square root of 3 over 2, comma 1/2, but it started with a negative instead. All that's left to do is deal with tangent. Tangent is sine over cosine. Tangent is sine divided by cosine. So we're just going to go through here and divide them. We'll hit the obvious ones first. We'll come back through and hit the not so obvious ones. Oh, something I noticed I forgot. I forgot this coordinate, which should be fairly obvious. -1, 0. And this one is 0, -1. Okay. Tangent's going to be in red. Here we go. 0 divided by 1 is 0. That one's not quite so obvious. We'll jump to this one. Square root of 2 over 2 divided by square root of 2 over 2. That is something divided by itself. That is 1. This one, not so obvious. We'll come back to it. 1 divided by 0 is undefined. Let's stop right there. Anytime we want to follow a tangent, we can just kind of go across the line right here. There we go. This one is the same as this one. Sine and everything. Negative square root of 2 over negative square root of 2 over 2. It's 1. This one is 0. This one is undefined. If I could spell. Undefined. Okay, let's hit a couple other ones that I think are obvious. Then we'll hit some of the other ones that are not obvious. These right here are the same thing with the opposite signs. When you divide a positive and a negative, you wind up with a negative. So negative square root of 2 over 2 over square root of 2 over 2, same thing with opposite signs. -1, same thing up here. Now let's hit these. So if you don't remember these, we can calculate them very easily. Let's close that parenthesis before it drives me insane. So here we go. We're going to divide 1/2 by square root of 3 over 2. Grab a scrap piece of paper here. Oh, I have one underneath. Lucky me. Alright, we're going to do this one, and then we're going to do this one, and then we'll be able to extrapolate with some signs. So, sine divided by cosine, 1/2 divided by square root of 3 over 2. What I'm about to do is perfectly legal, but it actually doesn't work if it was the numerators that I was canceling out. But 1/2 divided by square root of 3 over 2 gives us 1 over the square root of 3. Nobody likes that. We'll multiply by the square root of 3 over the square root of 3. And we get this. There we go. We just found this one right here. It is square root of 3 over 3. Let's go ahead and do that one. Square root of 3 over 2 divided by 1/2. We will cancel those out. Again, that would be completely illegal to cancel them out if they were numerators. I lied. It would be legal, but it would be a mess when simplifying. There's a slight trick to that one, so let's not even go there. But if they're denominators, let's go for it. So square root of 3 over 1, which is just simply the square root of 3. Square root of 3. Okay, we have enough information to finish everything we need to finish. We'll use some symmetry and some signs. This and this are the same with opposite signs. So, negative square root of 3 over 3. This one and this one are the same. Negative square root of 3. We can trace these lines. There it is. This and this are the exact same. Square root of 3 over 3. Square root of 3. We can trace that one up. So if you don't remember the unit circle, it's not that big a deal. All you need to do, all you have to do, is start by drawing the first quadrant. Most of what you need will be in the first quadrant most of the time, because the angles we deal with in trigonometry are predominantly acute angles. So if you can get this first quadrant done, which comes from the song, you'll be fine. And you just extrapolate, find signs, change the signs to get what you need, divide sine by cosine to get your tangent, and you'll be good.